then as a result, because today we have lots of energy and lots of motivation, today is Monday, we start the class from backwards. We just start, I should say, the lab tutorial sessions for the math advanced functions. Then we just go back, I should say, after the first break that we're going to have in 45 minutes. We're going to go back to, I should say, to the regular mathematics and advanced functions class. Okay, then please, guys, today, just if you have done a little stretching and you see the energy is coming back to your brain and mind, you are getting ready, please open your R Studio or your R session. Then we just start from our lab session. We are going to see some stressing stuff. Then we move back after the first break to the textbook and we continue with the regular advanced functions 12 then. Okay, I'm just gonna a little bit, I should say, do a bit of whiteboard session. Okay, let me just push this one a little bit up. Okay, it's fine now. Let me pick up a color. I call that Monday, July 13. Advanced functions, lab number 3. Okay. Then now it seems that you're ready. Now you're just moving to the things that you're going to do. Everyone is ready now? Yeah? Okay, if you say yes and you are ready to get started, let's recap what we have done so far. In our R Studio, what we did last week was that we had a kind of data sets. The data sets was called women. These data sets was essentially what? Was essentially a summary of 15 American women, which we got 2 characteristics of them. The first thing which we got from them, it was the height. And the second thing was the weight. Which essentially what we saw was something like that. We saw, I should say, for example, a table like this. We had the women on the first column. For example, we had women number 1, we had women number 2, number 3, and goes all the way to women number 15. Then the thing which we had over there was that, for example, we had their heights and we had their weights. For example, women number 1, probably its height was, let's say, for example, 50 inches, for example. The weight was, for example, 75 pounds. And we had all the way go down there. Okay, that was essentially, that was the data sets that we had. And we came over there and we said that, okay, when we had, for example, a first basic scenario, that in our basic scenario that we had, if we had, for example, let's see, I'm just gonna get, for example, let me put, for example, one number here. I say that, for example, the y-axis which I have, it's gonna represent, I should say, the women's height. and the x-axis which I had, it's going to represent the women weight. Then I said, okay, in case if I have, for example, one woman here, and this cross, it represents a point in the plane, which is essentially something very easy as this one. You say that, okay, for example, in order to see this woman's weight, you project it along the x-axis. You get, let's say, the x of A, and also for the y, for the height, you get it there. You get the y of A. And also imagine for the second woman, we had, for example, something like this. For the second woman, we had, let's say, for example, for this woman, we had, for example, its weight like that, represented as the xb, and its height represents as yb. You saw previously that when you are with this scenario, it's very easy to fit these 2 points together. And we were able, based on the things that you learned on the 2 chapters of the book, you saw that it is very easy now to come to develop, I should say, a mathematical formula for this secant line. If we can call it y equals to ax plus b. Because we said that in this very easy scenario, we say that a, which is going to be the slope of our case, which can be represented as average rate of change or instantaneous rate of change. We said that for this very easy scenario, we are going to come here and say that we are just going to go with the yb minus ya divided by xb minus xa, which is a representative of the average rate of change between these points, which is A, and this point, which is B, and find the secant line equation. However, we said that if we have this scenario, now instead of having 2 women, we said that we got to make it a little bit more complicated. And instead of having 2 women, we add 13 other women, as you will see. For example, that we have in total 15 women. And now the problem which we have right now here is that we just want to develop something like this. Okay, that's the purpose. That's we just want to find a straight line as before, but we cannot find a straight line to connect all these points together. This is impossible. It's not going to be a kind of a graph, straight line. Then we said that we are going to find a line something like this, that we say that this is going to be a very true representative of these 15 women there. And that was the purpose of the course that we did on last week. We said that we are going to come here, instead of finding a line which connects 2 points, now that we have a case that we have 15 points and it's impossible to find a straight line as a secant line representing all these 15 points by connecting one pairwise, then we find a one line, which as you remember, I asked you please to do a kind of a quick review on the concepts of the basic optimization concept that I'm going to talk about that tomorrow as an ordinary least square, which we talked at probably at the end of the session or at the beginning of the tomorrow, OLS. Then we said that by taking into account these criteria, it's a kind of a very basic optimization process that we have learned. We can find a line, something like this, that represents these 15 points together. That's the purpose. We say that, okay, now, before we just move to our art studio, we come as a general point, we say that, okay, the best line that you want to fit between these 2 points, for example, I should say, maybe you ask yourself why this line would represent the best fit. It's going to be a best representation of this line. You come here and say, I'm going to come here and say that the line, which I'm just going to introduce as a polynomial like this, you say that I'm going to say this one, the thick line which I have drawn, it's going to be a good representation of these points based on the concepts that we are going to learn later today, which is going to be the ordinary least squares, that it produces less error. Then as a result, we say that, okay, then we do not restrict ourselves with having only one single line. We do not say here that the secant line equation, it's going to be y equals to ax plus b, which was the line for the secant line. We say that the secant line that you want to write even can take the form of the polynomial of degree 2 that we learned it before. We said that on the polynomial degree 2, we said that it's going to be, for example, ax squared plus bx plus c. That was a thing that we learned it, I should say, on Friday. We said that this is going to be the polynomial of degree 2 because the highest degree which we have is going to be 2. And we have the coefficients. The coefficients which I have here, it's going to be A, it is B, and it is C. I say that these coefficients A, B, and C all belong to a set of the real numbers. And the X which I have is going to be what? The X which I have is going to be my variable. You see, X is going to be my variable. Then the degree of this polynomial was 2. Because of the 2 is the highest number. And also for the secant line, it is also a polynomial for us because you will see that in this polynomial, you have what? You have the highest degree of your variable is what? It is 1. Then this is also a polynomial, but of degree 1. You see that I should say A and B, the coefficients which you have, again as before, A and B belongs to the real number, and this polynomial is degree 1. And your only single variable which you have, it's going to be what? It's going to be the X. Also, you may come here, it's a very generalized format. We are going to talk about that, I should say, maybe tomorrow. But before we move on, you say that, okay, as long as you say, I have learned about the polynomials, that they can take any forms, I'm gonna represent these 15 women with a polynomial of degree 3. Guys, look at the beauty of the lab which we are having right now. We are having 15 women, height and weight, which is represented on the plot. And we say that we want to represent them by a single polynomial. That's the polynomial we learned on Friday. For example, the sky is the limit. You can have as many options as you want. And you say, okay, I just want to represent these women by a line which it's going to be a polynomial of degree 3. Polynomial of degree 3, you'll learn it on Friday. It's going to be represented by this line, by this equation, ax to the power 3 plus bx to the power 2 plus cx to the power 1 plus d. You say that, okay, that's going to be the line which I'm going to represent it. Then as a result, you say that, okay, this is the line which is going to represent my function. And you see that it's going to be polynomial of degree 3 because the highest power of your variable, which is x, is 3. We have 2, we have 1, and also d is a coefficient, which we call that intercept. And based on the things that we have learned also, we have to restrict our coefficients that a, b, and c, and d, a, b, c, and d should all belong to the real numbers. Then you say that this is gonna be my, for example, representation of these points if it is a polynomial of degree number 3. It is degree 3 because, as you will see, the highest power in your polynomials of your variable x this is your variable x, you see that the highest power is power number 3. That's polynomial degree 3. And that's essentially what you are going to do. That's what you are going to do, I should say, in a couple of seconds to fit, I should say, to represent these 15 American women by a mathematical equation. Okay, and now I'm just going to go to the next slide and finish my talk with the very last point before we just move on to the art environment. Guys, imagine that you are very interested to, for example, to fit your American woman by a polynomial which is going to be degree 2. You can fit it by a degree 1, which is simply a secant line probably, or you can fit it by a polynomial of degree 3 or degree 4, it doesn't matter. But we are going to see which one is going to be the best. We are going to talk about one criteria, that criteria, you check it, you see which one is going to be the best. Then you pick up, for example, polynomial number 1, degree 1, polynomial degree 2, polynomial degree 4. For example, we have polynomial degree 1, polynomial degree 2, degree 3, degree 4, degree 5. You can move on to degree 6. We're going to talk about the mechanism today that you say that, for example, polynomial degree 2 is the better option. We have a mathematical formula for it that you can assess which model, which polynomial is the best polynomial to represent this function. Then as a result, you come here and say that, okay, the American woman's height, it's represented by this equation, y equals to ax squared plus bx plus c, which we know that a, b, and c, they are going to be real numbers, and we know that the x, I know that the x which I have, it's going to represent the weight of these women, and also I know that the y is going to represent the height of these 15 American women. Then essentially you can just, you see that, for example, the height is a function of the weight, but as a second degree polynomial because the power is 2. Now the question is that, guys, then I can write it like that in order to make it much clearer. I can write it as a result, then I can write height is a function of A times weight to the power 2 plus B, which is gonna be weight to the power 1 plus C. Then you say that, okay, this model represents, I should say, the height and weight. A, B, and C, they are my coefficients, and I call C, as you remember from the previous one, it means that it's the intercept, which when we talk to the physical reality, I'm going to talk about that in a second. We see that how we can just interpret that in our case. But before that, I'm just going to finish my talk on these ones by saying something. Guys, remember, we had only 15 American women in our, for example, imagine that in the room which I'm right now, for example. Everyone is listening now? It's very important. And this part is gonna be the thing that we're gonna focus on it from tomorrow, which it means that we create a predictive model. And that's what I mean. Listen to this part very carefully. Then we move to the R studio or R session. Imagine that in the room which I am right now here, I have 15 American women. Let me go to, for example, represent it here. Let me be creative and use something like this. Please listen to this part. It is very important. Imagine that this is the room which I have 15 American women. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 women there. And I was able to represent these women's, and I know their height and weight. And I used this model, which I derived it here, as a best model which functions, describes these weights and height. Imagine that now. I'm gonna have another woman which is outside of this room. It's gonna be woman number 16. Listen to me. I got this model which you see right now here. I got this model based on 15 women. I mean that the intercepts which I derived for A and for B, these intercepts only represents the intercepts slope and the intercepts, the coefficients for just 15 women. Imagine now, I have another woman which is going to be woman number 16. This one is going to be woman number 16 standing outside of this room. This woman number 16 wants to get inside this room. Then can I predict and make a guess that how much is going to be its height based on this 15 woman which I have inside this room? Somebody said something? If that's the thing which you ask, that's going to be, I should say, the purpose of all these lab sessions that we have. The purpose is all these that we have initially 15 women's height and weight. We recorded each woman's height and weight. We find a polynomial of degree 2 or degree 3 or even degree 4 for these 15 women, which it corresponds, I should say, to the height of these women based on their weight. And we are going to see how we can just find an estimate for these coefficients A, B, and C. That's the purpose. But at the end of the day, if another woman steps inside the room, woman number 16, which it was not initially offered in our data sets, can I make a prediction or can I make a guess? How high is that woman? What is his height? If you wonder how, that's what do we call about that. We just want to make a prediction as a magician. Now that's our part starts. We want to become a predictor. We want to be a magician to make a prediction And that is why we call the model that we created here also a type of a predictive model. Why do I call that a predictive model? Because imagine that the 16 woman enters. You ask how much you weigh. You get its weight. You put the 16 woman weights inside this equation. For example, its weight is 65 pounds. For example, you type A times 65 pounds plus B times 65 pounds plus C, and you get what? The height of that woman. Then you see that you predicted the height of the woman, which it was not initially in your data sets. Then as a result, you come here to ask yourself, in order to do that, I see the importance, it has to be, let's say, to the power 2. 65 first to the power 2 because it comes from this one. This comes from this, and this one is this. Then you see that here, the importance of making a right estimate for A, B, and C. Then any other woman who enters the room, for example, there is another woman who enters the room from the other door, from the back door. For example, there is another woman who is going to enter the room from the back door, woman number 17. Then you can predict how high is that going to be, or she's that going to be. Does it make sense to everyone?
Yes.
Awesome. Then essentially remember this topic, that now whatever we are going to do, we are just going to first do 2 things. Let me go to the next slide. These are going to be our tasks that we want to do. Task number 1. Task number 1 is going to be very first. Find the right. I call it find the best. The best is the best word to use. Find the best polynomials to describe the data, which in our case is going to be American woman height and weight. This is our case here. It can be any other type of data. Then task number 2 is going to be to obtain a predictive model, which we have some tests also to make in order to make sure that the prediction is the accurate one that it's going to create. This is going to be our task. We finish it part 1 today and part 2 tomorrow. Then that's why remember this word, predictive model. Predictive model is essentially the thing that we are gonna, I should say, have lots of fun with it. And that's why we call that, it comes to artificial intelligence, machine learning, and later we talk about, before we finish the term, we talk about the neural networks. And that's the purpose of these tutorials. Then you see that from the polynomials that you learned on Friday, you are gonna make a predictive model. Then I should say, I'm just gonna come here and I put it here. Then our journey is gonna be this. And that's our journey. From the polynomials that we learned, we are just going to go to predictive models. And it's your role. I'm just going to go to the next line. And I'm just going to write your role. And your role, the thing which you do is that you act as a magician who can see the future. And that's going to be the thing, your role. You become a magician that you can see what's going to happen in future. And that's essentially, you see, this is going to be the power of the math and the polynomials that you have learned before. Okay. If you have no questions, we just go to the R. Any questions, guys?
No.
No? Okay. It's going to be all the tutorials that we wanted to talk about that for today. Okay, I'm just going to stop the share from, I should say, from this one. And I'm just going to go to the R Studio. And also, I'm just going to do this with the R. Laura, we did some part of it in the R on Friday. And I'm going to do that on R Studio. And in case if you have some problems, I go back to the R to do that, the same thing for you then. Okay?
Okay.
But please make sure that you follow the things that we do one by one.
Okay.
I'm going to start by the first comment. I'm just going to start by the first comment. My first comment is going to be this. My first comment, which I'm going to write, is going to be as a comment. I'm just going to write American. I put the hashtag sign, and it's the same thing. Everything is the same with the R, but the R Studio is much comfortable to work with because you have different panels, like for example, the packages, the plots, the files, the viewer. You have the console right now, and you have the data which you create on the global environment to see that. That's why I'm just doing this. And then I'm just going to press the hashtag, which is going to be essentially you press shift on your keyboard and press number 3. Then you find the hashtag, then shift number 3 is going to be the hashtag. It allows you to write something about the model without regarding it as a code to be. This is not a command to be done. Then it's going to be hashtag American, woman, height. It's going to be aged between 30 and 39. Average height and weight. This is a description which I write for myself. Then when I come back anytime in future, I know that what did it done. These are the things which we did that on Friday. I'm just going to review that. Then the first thing which I do, I'm just going to go to the file, save as. Then I'm just going to go save it. Let's say, for example, I'm going to create a folder. Oh my God, I have lots of short memory on my system. Lab codes. I create a file, which I call that lab codes. I'm going to press enter. And in my lab codes, it's a new folder which I created. I created women. The file is going to be women, and I put .r. It is very crucial that I save my file name with the .r because it's next time when you open it, it opens into the R Studio or any platform that you run the R. When I choose the woman name, the name can be anything. You can call it Monday or anything you want. Then you press save. Okay. Then you press save. You see the name which appears here on your script. It's now changed from Untitled to the woman. Also, you have it, Laura, in your R. You have it Untitled scripts. If you do the same thing, you see the name which you have created there. Okay. The next thing which I'm going to do, I'm just going to write a comment. I'm just going to write upload the data. I'm going to call that internal data, which is essentially I call it internal because you will see that for your homework, you are not going to use the data from the R. I give you data sets myself, then you call that external data. Okay, it's internal data. In order to write it, I know that the data set is called women. In order to run it, I'm just going to write it write data and put the woman inside the data sets, inside the data command. I have data, parentheses, women, parentheses closed. And now that I'm ready to run this, I'm going to control enter. If you are working with the R Studio, you see this data as a promise here. You can click on it. Or you can just come here to say the head. You write woman. If you do that, if you click it, you will see that you get the 6 elements of that, I should say, of that data sets. These are the things that we have seen, just to see what the data looks like. We have the first initial ones. You can show, for example, you can write show woman. Then you have all 15 ones. You see, when you write this command, which is show parentheses woman, it shows you all data sets. You see that you have 15 women. You see, you have 15 women, one go all the way to the 15, and you have for each one, you have its height and its weight. But in case when you have working with the huge data sets, then that's what we call the head. The head, it gives you the head of the data. Just some, look at that, when I run the head, I get only the first 6 women, height and weight. Okay, the next thing which we do, we said that we can write this structure, str, woman. Str, it shows the structure, that it means that how the data sets has been created. And for example, it shows that when you go to your console, you see the structure, the framework of your data sets. It shows here as a data frame. That's what we want. It shows that this is 15 OBS. OBS stands for observation. 15 women that you are studying in. It means that this is 15 observation of 2 variables. 2 variables, these are going to be your variables that we saw that on the whiteboard. We saw that one of them is going to be the y as a variable because it changes depending on how the x changes. And the other one is going to be the x variable. We said that, for example, it's going to be the weight. Then that's why we have 2 variables. One of them is height, one of them is weight. Then you have also the variables is listed down there. You have the height and you have the weight. That's what we talked at. I'm going to talk about what does it mean, the dollar sign. Look at the dollar sign. Everyone sees that?
Yes.
I'm going to talk, you know, what does it mean? I'm going to show that to you how we can work it. But look at that. In a second, we have, in front of the height and weight, we have NUM, stands for number. It means that the height and weight, they are numbers. That's what we expect. That, for example, if somebody asks you how tall you are or what is your weight, your answer is a number. You say that, for example, I am 62 feet. Sorry, not feet, it becomes a giant. 62 inch. Or I am, for example, 66 inch. That's the number. And also the same thing for weight is the same thing. It says that the weight is gonna be a number which is, for example, they ask you, how much do you weigh? Or how much weight do you have? You give a number as an answer. You say, I am 132 pounds, or I am 117 pounds. Then that's what it means. Then you see that, guys, the first thing which you do when you work with the data sets, when I give you the homework for your project, because as I said to you, I'm going to do 2 projects. On your project, always run this code, which is going to be the structures. We said that the structure of the data sets. And that's what it means. The structure, you set str and the name of the data, the woman. The structure of the data sets is always crucial to start with, to see how many variables do you have, how many observations it contains, and how many, for example, the numbers which it has. Okay, that's the first thing. The second thing which we do is going to be this. I'm just going to go over there and extract these 2 variables, the variables which I'm interested to work with. Look at this. In the data frame which I have the dollar sign. What does it mean? It means that, for example, we have X, for example, we have the height. If I write, for example, a woman, this is the name of data sets, and you see the dollar sign there, and I put the dollar sign next to woman, the dollar sign is going to be, I press shift and I press number 4. I'm going to do this, woman, dollar sign, height. Then I'm just going to run it. You see the line which I get here, it's going to be 58, 59, 60, goes all the way to the 72. It means that this is just the height which I extracted from my data sets. And also the same thing, you can come here, say woman, dollar sign, you're going to go for the weight, press enter, control enter, you see that you extracted these data sets. I'm going to come here and just put the hashtag, press shift number 3, and I write extract the variable of interest. These are the variables that you're interested in, that you are interested to work with. For example, you just want the height and weight. That's how you extract them. Sometimes, for example, for your homework, I'm just going to give you a data set which it has, let's say, 10 variables. Then you only need 2 variables. Then that's the way you extract the variables which you want and you want to work with. For example, I give you a box of tools, and the box of tools which I give you, it's going to be very heavy. You don't want to take that with yourself all the places that you go. Then what do? You take only 2 tools from the box, and it's going to be light. You carry this all the places that you want. And that's essentially what do I mean by extracting the variables of interest from those data sets. Then what I'm going to do, the other thing which I'm going to do is that then either I can always refer to this variable of interest like that, or I'm just going to save them into toName, into an object, and I call that object for the rest of my coding. That's what I'm going to do. In order to do that, I'm just going to call women height, because that's what we've been working with it. I'm just going to create a name. The name can be, you can call it Y. You can call it anything you want, but it's going to be something related to the nature of those features that it makes it easy for you in future to remember it. If I can call women's height, I call it apple. Then in future, when I go back to my codes, I have some problem to visualize and think, oh my God, the object which I have created as apple, what is that? Does it really mean apple, or it's women's height? And that's why the name should be very specific. I'm just going to call it simply, you can call it Y. You can put it equal to control enter. Or you can call it height. And for the weight, I'm just going to call it x equal to control enter. Huh? That's what I'm going to do. Okay. And now the thing which is going to be here is going to be this. These are the two things as an object which I create. And now you can also, instead of equal sign, if you just want to make it fancy, you can just use this sign. This and control enter. It does the same thing as equal. Sometimes I do this one because I prefer that one, but it depends on your choice. X and Y. You can call X and Y as height or weight. Then in future, whatever you want to do, you do not go back, I should say, to call them woman's $ height, woman $ weight. You call them by X and Y. And now, that's the things which we have done so far. It is essentially a basic introduction of how to sort out the data sets in the R environment. And now the thing which I'm going to do, I'm just going to run the first polynomial of degree 1 of my data set. Okay, I'm just going to go to run the first polynomial. And essentially, that's the thing that we want to do. We do degree 1 today, and for degree 2, we do that tomorrow. But also before that, I'm just going to do something else. I'm going to plot and visualize the data set. In order to visualize it, I'm going to do something. Before that, I'm just going to change these things which I created. Because height represents height, I'm just going to write it with the height, but with the S. And I'm going to S, I call it weights. It doesn't make a difference at all because these are the names. You can name them anything, but you see that in future, it's more beneficial to just call them rather than X and Y. Okay, now, in order to plot it, that's also what we did on Friday. We said that for the plot, we said that. In the command for the plot, we know the function. Before I move on, I'm just going to tell you something. When you, for example, when you need a function, you do not know how to fill this. Because now it's easy for me because I have done that many times. But if you're doing it for the first time and you do not know what to do, the best way in order to find the arguments is that to write the help, parentheses, and write the name of the functions which you do not know what is that. This is one of the benefits of working with the Art Studio. You see that when you write this stuff, it suggests many things to you. And now, I'm just going to press Control Enter. And you see that in the R Studio, it opens, there is a tab which is called Help. And the help is going to be here. If you are running the R, not the R Studio Lara, when you write help, parenthesis plot, it opens, let's say, your internet browser and it gives it help there. Is it correct, Laura?
Yes.
Yeah? Okay. Then by doing this, you will see that, okay, I have help, but help is created, and I'm just going to go with the first plot, which it says that. It shows you now what arguments do you need. You say that, you see that, for example, you need plot X and Y. These are the first two things which is important. Then I'm just going to come here to do the plot based on X and Y. What is going to be my X in these data sets? In the whiteboard which I created for you, do you remember on the X axis, did I put height or weight? It was my weights. And that's why I put the object which I created here as a weight. Because it refers to all the American weight, American woman weight. Then I'm just going to put a comma. Then I'm just going to write y equals to. For my y, it's going to be the y-axis. If you remember from those slides, I decided to describe height in terms of the weight. Then I put on the y-axis, I put that height. I press Control Enter. And you see the plot is created. That's the easiest way to create a plot. The x-axis, you will see it represents the weight. The height axis represents the height. The y-axis represents the height. But I do not have a title for my plot. It's very easy. I can come back to the plot and I put main equals to, and I put in quotation, because remember, when you do the coding, you can write the descriptions, the alphabets in two formats. Either your format is going to be with the hashtag as a guidance of what you do, or if this is part of the code, it's going to be inside the quotation mark. I'm just going to write the name of my that plot, American woman, age 30 to 39, Control Enter, and you see this title is showed up in bold fonts on top of my plot. That's going to be the title of my plot. Why do I need to see the title of my plot? That's the reason, because sometimes it's good to, I should say, when you look at your plot, you see what it describes to you. It's a kind of a guidance. It's a kind of a help. You see that, what is that going to talk about then? Okay, essentially, these things was a quick review of all the things that we did on Friday, but I reviewed that for you with more explanations that we do some kind, we get ready for the next stage, that the next stage is going to be to run our very first polynomials of degree 1 for these data sets, which is going to be the next thing that we're going to do. But right now it's almost 1 hour we have been working. Now I just want to give you the break. When we come back from the coffee break, we are going to see that how we can just run our first model based on the things that we have created so far. But we come back after the break to talk about this one then. But before we go for the break, any questions? Everyone is okay so far? You have all created up to this point, which is a plot?
Yes.
Yes.
Sylvia, Lara, Anki, and Jasper.
Yes.
Yes.
Everyone is fine, huh?
Yes.
Awesome. Then guys, the time is 9:43. We take 15 minutes for a coffee break. Please come back to the session by 9:44 then. Come back by sharp 10. We continue with the rest of the class. Okay.
Okay.
Awesome. See you guys sharp 10. Resume the recording. I'm just going to share the screen with you on, I should say, on our studio. Okay. And now, okay, let's get started. Okay, now that we were able to plot the function. Now, the thing right now here is that we are just going to run the very first model. the first model that we are just going to run, and let's see, uh, how can we just do some kind of diagnostics also for it, is going to be the polynomial of degree 1. Polynomial of degree 1, it means what? And as I showed that to you on, I should say on the whiteboard, let me do that once more. If you remember, the polynomial of degree number 1 for our case was this. We know that the polynomial of degree number 1 is essentially this one, the strict line equation that we have it, ax plus b. We know that the a, it is called the intercept slope, b, it's called the intercept, and I know that the power is 1 for the x, and that is the reason we call that polynomial of degree 1, because the exponents of the highest exponents of a variable in the entire, I should say, model is just 1. And that's the thing that we know that. We know that also a and b, both of them, slope and intercepts, should be a member of the real numbers. In our very special case that we are going to come here and say this one. We are going to say, okay, y represents the height. Then it becomes like that. We say that the height of a woman should be equal to a times that woman's weight plus the, you see the woman's to the weight is going to be, has the power 1, as exactly as we have on, I should say, the framework which we have there. And you see that that's what we mean. When we go back to the R Studio, and when we just want to model this height and weight into our model, you see that how we just connect height and weight together. That's what I mean. You see that we have the power of 1 for the weight, and also that's the thing we just want to do. But remember, before we move there, I just want to highlight something for you. The thing that you want to do, guys, all the problems that we have 2 steps. First step is that we decide on the degree of the polynomials that we want to have. Here we said it's going to be degree 1. If we decide on degree 1, we have slope and the intercept, which we do not know how much they are. I put the question marks on top of them. We do not know how much they are. And the purpose of modeling that we're going to do today right now, before we go for the second break and the final break, is this: to see the mechanism that A and B are going to be derived. We call that to be estimated or to be inferred. And that's the plan that we're going to have right now. Then. Okay. Let me arrange these ones here. Okay, now I have this one. Now I can just, I should say, go back to the R Studio and share the screen with you on R Studio. Okay, now, in order to run the model, we just start by this. We say that, okay, guys, in the model that we have, what is our y-axis? It's the height, correct? That's what we want to just have a function of. Then when we just want to write, I'm just going to do this one. I'm just going to find the heights of American women. Either you can write it as women's $ height, which is the extractions of the heights, or you can just use it, the name of the objects that you created. Look at that, because we have the equal sign there, it means that they have to be equal. It doesn't matter if I'm just gonna just pick up the right side, or it doesn't matter if I just wanna pick up whatever I have on the left side. Okay, and that's the criteria we are looking into this. Then as a result, I can come here to write woman $ height, which is essentially the height of all American women. Or I say, why should I bother to write these long, I should say, word? I simply call it heights, because I did the same object created here. You see that? I say heights is going to be a function of the weight in a polynomial degree 1. In order, listen to this very carefully, in order to show these functions in R, you write tilde. Guys, this is called the tilde. It's gonna be, it's on the keyboard. I expect to find that key under the escape button at the very top left corner, at the very, very top left corner, when you can see number 1, F1, F2, it's going to be probably on the left side of key number 1. Probably it's going to be there. Press Shift, press that key, you see the tilde sign. Everybody found it?
Yes.
Okay, then I should say height, tilde. I'm just gonna, you see that in the plot also, we have the weights and we have the heights. I'm just gonna height, it's gonna be a function of the weight. For the weight, I can just write again, woman, $ weight, which it extracts all the components and all the elements, which is denoted by the weight of all those 15 women. But before, I remember I created an object which is called the weights. Weights essentially represents all of this. Then I can just erase it and I write simply weights or whatever you have written. Okay, this is the functions which we have, correct? You see that in the model, we had this. We had A times weight plus intercept. A was our slope, B was our intercept. However, when we want to make an estimate of them in the R, we do not show them explicitly. We do not write them. When we say height is a function of the weights, R is smart. He can understand you that you mean that height is a function of weights. It's a degree 1 polynomial, and the intercept is going to be A and B, but it's not going to write it there. And that's all you show. Does it make sense, everyone? That's how you show the function. But in order to show the function, we come here to use a command. The command is going to be this one. We call that linear model. We call that LM parenthesis. It's L stands for linear, M stands for model. That's the function which it helps you to make an inference and estimates about the slope and intercept. You do not need to just have your pen and paper, find the average rate of change for every pair of points, then there is no need. With one single line, you can find it. If you do not know how to just do with the LM, you see that, as I told you, you just write help, you write LM control inter. And you see that if you're using the R Studio, you see on the Help tab, this one there, LM, it's the fitting linear models. And if you are, Laura, using the R, you should have one internet browser open already for you then. Do you have it, Laura?
Yes.
Okay. If you go to see the help, you see that you have two things which is crucial, formula and data. We only use these two arguments today. These two arguments are essential. Now, in order to do that, you just go back into the LM function. It's written the first argument, it's written formula. I'm gonna write formula equal to, and I'm just gonna write the formula like this. I'm gonna cut it, bring it here, and paste it. Then the formula is essentially the representation of your polynomials, except that you do not show the intercepts and the slope. You only, by writing the tilde, you show that which one is going to be a function of which. You see, I have no a as the slope, and I have no b as an intercept. Only the height, which means that by the tilde, means it's going to be the weight, function of the weights. It's my first argument, as you see on the help menu. Help menu says that LM parenthesis formula, comma, data. For the data, that's what we are gonna do here. I'm gonna put the comma, and I'm just gonna press space. And for the data equal, and it tells you to the R, this function that you want to create is gonna be found there. These functions that you want to create, it can be found in which type of the data sets. What data sets that you are? You are working on the data sets that we have 50 American women aged 30 to 39 years old, which we had the average height and average weight. This description should remind you of which type of data sets. The data sets was women, huh? Correct?
Yes.
That's right. And now, guys, congratulations to all of you. You are able to, you finished your first predictive model in the entire, I should say, the math course that you have taken so far. And you are done. We are essentially done. Now, you want to run it, you press Control Enter, and the model is run. And there it is. Still, we have something to do in order to represent it more. But if our first initial step, I have to just call this model a name as an object to create it there. But before that, you see that when you run it, it shows you something on your console. Everyone is so far good. Everyone was able to just run this code.
Yes.
How about Sylvia, Anki, and Jasper?
Yes.
Yeah.
Everyone did great? Everyone run the model? You have no problems? Okay, that's good then. Then guys, please remember, ask me any questions, any stage that you have, because you have to use these methods to go for your first project. Okay, now, when you run this model, if you go to the console which you have, either in RStudio or the R environment, when you just go there, you will see that you have something which is called dot. You see that? It's reminding you of the formula which you had. It is written as LM, which stands for the linear model, and formula height a function of the weights data woman. It's exactly the same model which you wrote there. It's reminding you what model did you use. But look at here. That's our preliminary investigation into our model. We have coefficients, which one of them is called intercept. Guys, listen to this very carefully. All the things which you are gonna do, I should say, from next week when you start working on your project, it's all about your interpretation and working with these data. We have a column, we have a type of, I should say, data. They call that coefficients. What does it mean, coefficients? It means that if you go back to your linear model, which it was the polynomial of degree 1, which we had y equals to ax plus b, our y was the height, our x was the weight, then we had coefficients a and b. You remember it, everyone? These coefficients, which it was a and b, these are the coefficients that we had to find them based on women's height and weight. By writing the model of single line like this, which we did, now these coefficients are decided on. Look at this one. It means that your b, which it was the coefficient intercept, it's 25 point. It's your b is what? Is 25.72, and your weights, the slope for the weights as your, I should say, as your what? As your variable is gonna be what? 0.2872, which is your A, this is your B. Everyone has the same thing? I'm just gonna go to show you something on, I should say on, guys, before I just move on, everybody is doing fine? Everybody got the same answers as an intercept and the slope for the weight?
Yes.
How about, thanks Laura, how about Celia and Anki?
Yes.
Yes.
Oh my God, it's very impressive. If you are just coming all the way like that, you do not get the error message, it means that you are doing a pretty good job. Awesome, guys, awesome. Then guys, remember these 2 points and have it in front of you. I'm just gonna, I should say, stop the share and I just go to the whiteboard. In the whiteboard which I have, look at this. It was the model which I was interested to make an inference. And the value, you see that I put the question mark on it? Yes? These are the values which I got it from, I should say, the model which I did in the R. Then what does it mean? It means that if I come here, I can write the same model like that after I just made the inference, that the height of these women equals to what value did I get for the A? How much was it? It was 0.2872 times the weight plus B. What is the B? How much did I get from my code in R? It was 25.72, correct? This is essentially, that's what we were looking for in our model. This is our intercept This is going to be what? Our slope of the model. Guys, any questions?
No.
No? Okay.
No.
Fantastic. You see that these 2 points, I got it from there. You see how life is easy now? You see that? How life becomes extremely easy. And now, the thing that we want to do right now is this. The thing that we want to do right now is this. We come here to say that what these values means. You remember, we talked about, I should say, the average rate of change. When we talked about the average rate of change, I'm just going to go for the interpretation before we just go back to the model then. We said that the average rate of change, we said that, for example, here in our very special case, which we know that it's going to be y2 minus y1. It's going to be height of women B minus height of woman A divided by the rate of women B minus the rate of woman A. That's essentially what does it mean. Which we got that to be equal to what? Equal to 0.2872. Based on the interpretation, what does it mean? I'm just going to write it here because it's very important. I call that interpretation of A, slope A. What does it mean? It means that, guys, based on the things that we learned of our course in average rate of change and instantaneous rate of change, we said what? This one represents what? It means that for any first of all, okay, I might do interpretation based on the things which I remember. Before that, just I remember, maybe it was a couple of days ago, we say here, before we move on, we said that the sign of, I should say, the sign of this slope is very important. The sign that we got for this slope is what? Is positive. Huh? I'm going to write the interpretation as 1. Interpretation of slope A. Because the sign, because A slope is positive, it means that if weight increases, also height would increase, or vice versa. Okay, it's going to be the first interpretation. We said that the sign of the number which we get is, guys, is very important. It took for me many long time to understand how to interpret I should say, the sign of this slope. Because the sign of this slope is positive, and as you will see that, then as a result, this is gonna be, I should say, this conclusion. For the second one, I'm gonna write this one. This one is very important. For any unit change in the weights, the height would change by 0.2872, and it's gonna be what? For the height, we just talked about the inches. This is also very crucial. Then we have, I should say, true interpretation. These two interpretations is extremely important. And one of them is essentially a direct consequence of the positive sign here. And I'm just gonna write it important. If this is positive, it means that the weight and the height, they are just in the direct relationship. If the weight increases, the height increases. You see that from the previous week, we saw that if it becomes negative, when we talked about the math behind it, we saw that if it's negative, it means that if the weight increases, the height decreases, or vice versa. If the weight decreases, the height increases. They are just moving in the opposite direction. One goes up, the other one goes down. The other one goes up, the other one goes down, if the sign is negative. But if the sign is positive, it means that if one goes up, the other one proportionally with respect to the slope, it goes up. If one goes down, the other one also goes down. And that's the significance of the sign of the slope. And also the other interpretation, which is very important, is going to be this, that for any unit change at the denominator, which is going to be the weight, the numerator, which is going to be the height, changes by this value, which is going to be the slope. Guys, these things are very important. Please take care of this as hard as you can. Okay, please write these notes.
Okay.
These are extremely, oh my God, I do not know how to emphasize that. It's important. Thanks, Laura, and thanks everyone. You're almost coming to an end for today's lab session. Today's lab session was a little bit longer, and the reason for it is that we couldn't catch up enough on the previous week. That's why we're just pushing towards it to much higher this term now. Then that's why. Okay. Now, seems that everything is fine. Anybody has a question now?
No.
No. Guys, I recommend you just take that slide, print it like that, and put it inside, I should say, a frame, and hang it on a wall, that you can always remember these two interpretations, because these are very important. Okay, now I'm going to go back to the R studio, and that's the things that we did so far. Okay. Okay, now what time is it now? It's 10:32. We're going to wrap up the thing so quickly. Then we just go for our final break, coffee break. Then we come back. We're going to finish, go back to the book. Okay, now, so far, the things that we did to run this model which we created, and we just moved on. We were able to just find an estimates for these values, and that was pretty much it. But now, the thing that we want to do is this. We just want to extract more information from this model. So far, the thing that we did was tremendous, was incredible, because we were able to, in our linear model that we talked about that, we were able to just find the estimates for the intercepts and the slope. But we do not have any idea if this model, a polynomial of degree 1, is the best choice, or if I could have done the polynomial of degree 2. I do not have any idea. Then right now, I just want to see how can I just extract information from this model, which it helps me to compare this to the other models that I may have. Okay, in order to do that, I'm just gonna put a name. I call model equal to this one. You can call it anything you want. The best name which I can just call it is just that I'm just gonna call it the model. The model is the best thing which we can do. Name it model, you can name it fit, you can name it a house, you can name it an apple, you can name it anything, you can name it a pencil, but model is a good thing which relates to the thing which we have done. I create a name model, it's an object which I'm just gonna just do what? I'm just gonna store all the informations from the model which I have created into that thing. Then in future, in the next 100 years, I can always come back to the name model instead of writing its name. What is the difference? Look at that. Guys, I'm going to say the difference, how the difference is that in a real, for example. Imagine I'm your teacher. When you want to talk about me to the other classmates in your school, you want to talk about me and you say, okay, we have a teacher, his height is 6'2" feet. His weight is, let's say, 85 kilogram. He has dark skins. Sometimes he has beard. He's getting bald. He wears a t-shirt which is blue. You see, when you want to talk about me, you come with lots of details. But how about me? You put a name on me and call me Omid. Then whenever you talk about me, you say they have a teacher, his name is Omid. When you say Omid, everyone remembers me. Everyone knows that I'm 6'2" feet, I'm 85 kilograms, I grow beard, I'm getting bald, everything, every details. You see the difference? And that's why I'm just gonna call this one model. Instead of writing about this, I'm just gonna call it anytime which I want. Now, in order to extract more information from this model which I have, the thing that you do, you want to just run a summary information from the model. You want to do a summary. It's a very powerful, I should say, technique. You say that the summary, parentheses open and parentheses closed. With the summary, I come here, put my name there, Omid, for example. But for your case, it's gonna be the model, because we are gonna extract the summary of all the information which is encapsulated and captured inside the linear model which you created about the women's height and weight. Then I put the summary, parentheses, inside I put the name of the object which describes this model, control enter. And there it is, there I am. Everyone is okay so far?
Yes.
Awesome.
Yes.
Guys, look at this. Please listen to these ones. This part is very important. And when you just run your project, you have to run the summary of your model which you create in your project. And based on the things which I'm going to talk about that, you are going to explain about this. Okay? Then listen to this very carefully. I think we should be able to finish it very soon. Then we just go for our next coffee break. This is going to be our last one today. Okay, now look at this. I created the object model, which describes the linear model which represents the height and weights of those American women in that data sets. When I run the summary of the model, if you create apple here, you have to run the summary on the apple. It means that whatever name you have there, you put the same name here. Okay, what's going to happen right now here? The thing is this. We just come here and say, okay, we just go ahead with the call. It comes with the call. It says that, okay, the model which you have, the model which you have created, it reminds you of it. It says that, remember, the model is in the women data sets which you decided to have a function which represents height as a function of these women's weights. We do not talk about the residuals at this stage, but we just move on, jump into the coefficients of your model there. The coefficients is the same thing which you derived before you put the object name model and you run the model, execute the model. Then you got the coefficients for the intercept and the slope. But here you have a different representation which it contains a tremendous amount of useful information. Those ones which is necessary for us, we're going to cover it here. And this one is, if you compare these ones, you have a column which is called estimate. Everyone sees that?
Yes.
You have an estimate for the intercepts, which is V. We get the same number which we got it before, 25.72. And our estimates for the slope of your variable weight is going to be 0.207249. This is essentially the thing which we derived from the model before we run the summary of the model. However, and also we talked about the significance of them. However, we have other columns which stands for standard error. We have the t-value and we have the probability p-value. I'm not going to talk about these ones tonight now, but at this stage, the thing which I'm going to talk about this is going to be this. I'm not going to go into the details of what is going to be the p-value. When we move on our next tutorials, when we have more models to talk about, gradually I'm going to introduce you the concepts of the p-value that we take it as a threshold for finding the significance of that variable, which it means that it's going to be less than 5% or 0.05. Anything which is going to be less than that is going to be significant in our model. At this stage, I'm not going to introduce that concepts to you on the future tutorials. I'm going to gradually incorporate that thing into our tutorials. But look at these ones. Look at these stars. You see that? I have 3 stars there, and I have 3 stars here. Everyone has the same thing, huh? If you have a 3 star, it means that the number which you got for the intercepts and weights is very important and is very significant in constructing your model. In future tutorials, I'm going to show that to you, that we have some cases that we have 1 star. For some cases, we have no star at all. We have no star at all. We may have 1 star. We may have 2 stars. We may have 3 stars. The higher number of the stars you get, you should be happier. It shows that that number, it plays a role. For example, when you do a great job on your quiz and you get a good mark, I give you stars. The higher stars you get, it means that the better job you have done. Then the maximum of 3 stars means that number and that variable is crucial in building your model. We are going to talk about that, I should say, in future. And also, we come here on the next lines here. At this stage, I'm going to talk about, I should say, the multiple R squared that we have. I'm going to talk about the residual standard error tomorrow. But I'm going to, at this stage, talk about the multiple R squared. And the multiple R squared, what does it mean? And tomorrow, and on the next tutorials, we're going to talk about, I should say, the residual standard errors and F statistics. But today, I'm going to talk about the multiple R squared. That's the thing that it's required for us. Multiple R squared, how much is that? Is 0.991. How much percent is that? You multiply that by 100, then it means that 99.1%, correct?
Yes.
Yes. It means what? It means that the model which you have created has been able to capture almost 99% variation. Or let's put that into a simple, I should say, language. The information which was brought by those 15 women in terms of their height and weight. The model which you created, it captures 99% of the information or the variation between those 15 women. Then it means that the higher number of the information which your model captures and encapsulate, the higher efficient your model would be. Then, for example, if you have a model A, which it gives you multiple R squared of 99%, and the model B, which it gives you the multiple R squared of 80%, which model is going to be the best one? The one which it gives you the higher, I should say, level of the information which you have been capturing into that model. Now we have 99%. It seems that this is going to be a good one. It's trying to encapsulate all the information which the model needed to, I should say, to represent all those 15 women inside your model. Does it make sense to everyone?
Yes.
Everyone is fine?
Yeah.
Yes.
Okay. Awesome, awesome. Okay, we have, I should say, lots of things to do. However, let me finish today by one very simple thing. Tomorrow, our lab session is going to be much shorter, fewer contents, because today, as I said, it was much longer because we had to catch up with many sessions which we missed. But from tomorrow, we have shorter lab session, less content, but more efficient. Okay. Now, let's go to do the very last thing. And tomorrow, when we come back, we incorporate more information about this model. We finish at this point, but tomorrow we move on with more details of the summary that we run. And we show the prediction of these models. But in order to finish it, I'm just going to go back to plot the model. The plot that we had for the model, you see that we had American woman aged, this is the line which we had, the plot X as weights, Y as heights, and we put the name of the plot, American woman age 30 to 39. Everyone please go back to the same plot, and you see the plot which we created. Look at this plot. Every single dots in that plot represents one of those 15 American women. For example, this one is one woman. For example, her name is Jessica. For example, her weight is this when you project it down to the weight, and her height is this when you project it to there. And we have these 15 women all scattered on our line. Now, the model which we estimated, it gives us a slope, and it also gives us one intercept. That's right. Our slope was A 0.287249. Our intercept was 25.72, correct? I'm gonna say, guys, it's gonna be our model of the line. If you remember from the whiteboard session that we had before our first coffee break, we said that this line, it's a kind of the best representation that it describes the variations of the heights and weights of these women. If you wanted to plot it, you have your ruler. For example, you get 2 points and you connect these 2 points. But now you have 15 points. How to draw the line? In order to draw the line, I'm just going to write it here. I'm going to write it here. Plot the estimated line, if that's the best word to use it. Okay, how is that going to be the plot? In order to plot it, because that's going to be a straight line, because it's going to be y equals ax plus b, we use this line, AB line, parentheses. You see A, B, A, B, C, D, E, F, G, H, or you do not go that far. You write A, B, then the line, because you are going to create a line. And in order to draw it, you put the object, the model which you created, because the model that you created, it contains the numerical value for your slope, which is A, and the numerical value for the intercept, which is going to be the B, which we drive it here to be these two numbers, 25.72 for the intercepts and 0.2872 for the slope. And when I do that, I'm just going to run this, execute it, AB line, parentheses model. Then you see on your plot, there is a line which is the best estimate which you can find if you incorporate the model as a line which we created. Everyone sees that? Everyone can see the line?
Yes.
And you see that this is not the best one, because you see that you have one person here, one woman here, is not exactly to the line. And there is one woman at the far end, the woman number 15 here, is too far away from the line. This woman is a good fit for the line. He is exactly standing on the line. But these women in the middle, they are not bad. They can be okay. The distance which they have to the line which we plotted here, isn't that bad. They are so close to it. These women are perfect. They are just standing on the line. But some of these women, which they are at the beginning, at these women which were at the end of the line, it seems that they are not exactly a good ones, because they are standing in a higher distance compared to the line that we plotted. You see that? Everyone is fine so far?
Yes.
And guys, you see that so far in our lab, which ends today right now, we have been able to use all the things that we learned from the very first day, which we talked about the average rate of change, the instantaneous rate of change. We talked about Friday on the polynomials, and we talked about the degrees of the polynomials. We have been able right now to put this into action. So far, so good?
Yes.
Those things that you learn on the paper, you see this in the real physical world. Isn't that nice? Okay, now, guys, the lab is finished now. Sorry, today it took so long because we had to incorporate so much details. Tomorrow it's going to be much, much shorter. If you have no questions, we finish our session today. Just for the lab, we take the second coffee break. When we come back, we go to the book. We just continue with the polynomial session. Is it good? No questions?
No question.
No? Okay, guys, please take your next break. I assume that the time is going to be 10:54. Take it 54. Come back, I should say, by 11:10. Okay, come back, please, by 11:10. Then we continue, I should say, with the rest of the book. Okay,
Okay.
if you have no questions. Then please, guys, remember, before we leave, remember, save at the end of the things which we have done. I forgot to say that. At the end of the things which we have done, it's good to do that more frequently. I made a mistake. I forgot to do that. You go back to the file. You go scroll down all the way because you save as once. You save as once at the beginning, and each stage you press save. Then it makes sure that the things which you have created so far, it is saved and it's not going to be lost for tomorrow then. Don't forget, before you close your R Studio or the R session, please go back to the file, scroll down, you see the save button, press save. Or the shortcut, press Control, press S on your keyboard then. Don't forget to do that. Otherwise, you're going to lose all the things which you have done. Okay?
Okay.
Nice. The lab session is going to be done. Then, guys, I'm going to see you in 15 minutes by 11:10 to continue with the rest of the book. Okay?
Okay.
Okay. See you then if you have no questions. Don't forget to continue to practice even after the session. Go back again to rewrite these codes then. Okay. See you later then.